into this question, we need to find the maximum acceleration. That is maximum acceleration. Maximum acceleration of a train. Okay, so in this question, a train moves from one station to another. Okay, and it takes 2 hours of time. You can see this is on the x-axis. We have the time which is plotted. So from 0 to 2 hours of time. In 2 hours of time, the train covers some distance. Okay, and what is the distance which is covered? You can see the with a speed of 40, maximum speed of 40, 20 and 40 is the speed which is plotted against the y-axis. We need to find what is the distance covered and what is the maximum acceleration during this maximum acceleration, what is the corresponding distance which is covered by the train, that we need to find, right? So a train moves from one station to another in 2 hours of time. Its speed during the motion is shown in the graph, as you can see, right? Determine the maximum acceleration during the journey. Also calculate the distance covered during the time interval from 0.75 to 1 hour, right? So here you can see, let's say this is P, this is Q, where it is striking the x-axis. Now, it has been asked that what is the maximum acceleration? So students, we know that the slope of the velocity time graph. This is velocity, this is time, right? This is velocity, speed is velocity. This is velocity and this is time. So the slope of the velocity time graphs gives acceleration, and it is clear from the graph that the maximum slope is between C to D. You can see C to D. So the maximum acceleration is is given during the time period is attained by the train during the phase of C to D. So we can see maximum acceleration will be achieved during the journey from portion C to D, from C to D, right? And what is the formula of acceleration? Acceleration is change in velocity, that is change in delta, let's say delta, change in velocity by change in time. And during the CD part, what is the change in velocity? Here it attains a velocity of 40 and here it's attained a velocity of 20. You can see here 40 and 20. So it will be, the change will be 40 minus 20 into the numerator, kilometer per hour, divided by time. What is the time from this to this? 0.75 to 1. That is 1 minus 0.75 is can be written as 3 by 4 hour, right? So 1 minus 3 by 4 in hour. So this will give you 40 minus 20 is 20 and 4 minus 3 by 4 is 1 by 4. So this will give you 20 into 4. This is kilometer per hour square. So this will give you 80 kilometer per hour square as the maximum acceleration. This will be the maximum acceleration achieved by this train, and that is achieved during the portion of C to D, right? In this way we have calculated the maximum acceleration. So that is 80 kilometer per hour square. What is the distance which is covered during this time, that means during C to D. So the distance covered during this time is the portion or the area under the corresponding velocity time graph. This is velocity time graph, and under CD this will be the area which will be covered. Right? So for this area, how to calculate this area? So distance is given as area of, what is the shape of this? CPQD, area of, it's a trapezium. Why trapezium? I will explain. Area of trapezium CPQD. CPQD. Because CP and DQ being perpendicular, you can see, right? These are parallel lines. CP is parallel to QD, right? And if a pair of parallel lines, and this is the distance between them, then CPQD is a trapezium. So the area of the trapezium will give you the distance, right? That is half into sum of parallel sides. That means half of CP plus QD, right? Multiplied by the distance between the parallel lines, that is PQ. And what is the value of CP and QD? CP is 20, right? 20. Because this is 20, so this CP will be 20. 20 plus QD. What is QD? It is 40. We have already seen it. Q to D, this will be equal to this much, which is plotted in Y. So when we extend this, you will get the length of QD, which is 40. Now PQ. The PQ is 1 minus 0.75. That is 1 minus 3 by 4, which will give you 1 by 4. Right? So this much of kilometer is the distance covered during the moment when this train attains a maximum acceleration, that is from C to D. So area under the plot of velocity time during this interval will be given by the area of trapezium CPQD, which we are calculating. Now 20 plus 40 is 60. 60 by 4 is 15. So 15 by 2 kilometer or 7.5 kilometer is the distance which is covered by the train during this moment when the maximum acceleration is achieved, right? So this is the distance which is calculated. I hope you like the solution, students. If you find it good, you can like and subscribe. Thank you so much for watching. Bye bye.